has qualified state eligibility test CSI UGC NET in Earth Sciences. He has published his research works in various national and international journals. He has visited various countries to present his research findings in seminars and conferences, and he joined Central University of Kerala in 2016. With these few words, I welcome you, sir, to this webinar. You may start your presentation now. Over to you, sir.
Thank you. First of all, I extend my thanks to Dr. Taslima for inviting me. I will do one thing. I will share my presentation first, and in the meantime, I will mute my video for getting some clarity in the voice. So I'm muting my video, and I'm going to the sharing screen. Just a minute. Can you see my screen?
Yes, sir. Sir, please change into presentation mode.
Yes, yes. Is it okay now?
Okay.
Okay. Thank you. Once again, thank you for the invitation. So the topic which I selected for today's lecture is geospatial technology and data management. Let me introduce myself first. I'm basically a hardcore geologist, but I have some passion towards computational geoscience. It's a branch of geoscience in which we mainly deals with the geospatial data science and geospatial technology. So I have no idea about the audience category, but I assume that they are mainly from computer science and electronics backgrounds, especially I expect they are from engineering colleges or from the PG colleges nearby Kasaragod. Anyway, if I introduce this talk in a geoscience department, I will start with the geospatial technology and I will move to the data management. But today I will start in the reverse order. We'll start from data management and then we'll slowly move to geospatial technology because geoscience is a little bit, you're not familiar with the geoscience, so we'll start with the data management. So I think everybody is aware about data and data management because in computer science nowadays data is a hot topic. Everybody is talking about data, and there is a cliche that data is the next decade's oil. It's true because the data is providing more employment opportunity for, especially for the computer science students and students from the IT background. So there is a clear picture about data science and big data in computer science background, but for others, I still believe that data is, there is a lot of ambiguity regarding data, what exactly data is and what is data science. So if any layman's present in this meeting, I will just start from the introduction of data. What exactly data is? So that's the big question. What is a data? And the answer is also very interesting. What is not? Because data, everything we can consider as data. In data science, the data scientists are mainly, managing the data. They are collecting the data. They are processing data. They are, transforming data from one form to other form. And during this process, they use different technologies to process the data. So that there comes the artificial intelligence, machine learning, and deep learning. So data scientist knows what is this artificial intelligence, application of artificial intelligence in data science and machine learning, the significance of machine learning in data science and deep learning in data science. So all these are interrelated. So you can simply say that the machine learning and deep learning is a subset of artificial intelligence. So the concept of artificial intelligence was there prior to this data science. You might hear about the autonomous systems, like in the automobile industry, you might see the robotic hands working there in the automobile industry. Those are the primitive version of artificial intelligence, but they have a restricted intelligence only. They are repeating the words again and again. But Tesla's autonomous car is the best example for artificial intelligence. You can take that car to any unknown terrain and you can drive through the entire, you can, even you can drive in an unknown terrain also, because there is no need of any data feeding in that particular vehicle, because it is autonomous and it can adapt with it. Then machine learning. Machine learning is, it's a statistic-based analysis. Basically, it's a subset of artificial intelligence. So we are using artificial intelligence supported softwares or the backends to process the data in machine learning, and deep learning is further detailed in nature. So most probably we are discussing neural networks and other type of data management in the deep learning. So I think the IT people knows this, what is this, but for a layman, it is still confusing what is data. So we'll start with a common example from a native, a village man's perspective. So when I was a child, it was, in the 90s, the authentic data available in a home or an average home in Kerala is only 1 or 2, a maximum 3 data are available. The first one is called a title deed. You know what is title deed? Title deed is the ownership document of your land or property. So this document will be available. This document is available with you after the registration. So if you are, suppose you are purchasing a land, you will negotiate with your neighbor or a known person, and you will come into a mutual agreement that we are purchasing this land, and then you will go to the registration department. There you register the land, and during the registration time, the registration department will make an entry in a register, and that register may be stored in their almaras, and that will be an authentic record of or the proof of your ownership. And the document you may taken to your home, that will be your proof or your record. And maybe after some time, the registration department may transfer some data to the taluk office and the village office. They may also create some amount of record in your name, and they may charge a little bit, and then they will give you some receipt, and that receipt is also a authentic record that we call the tax receipt. Apart from these two, one more data was available in those times, which is called a ration card. In fact, this ration card is the proof of our existence during that time, because that time there was no Aadhaar card, no PAN card. Nothing was there. PAN card was there, but Aadhaar card was not there. Voter ID card was not there. So ration card was considered as the proof of identity. So these are the 3 common data available in an average Kerala family during the 90s. And these data were managed by the government, and it has its own structure, and it was stored in a very safe place. Only the government officials have access towards this data, and rest is with you. The proof is with you, and the record is in the government office. No other people can access this data. So this is the stage of data in 90s. And what is the status of data in today? When a baby is born, the very next moment, the hospital people will open a record in baby's name. That record may be the weight of the baby, the date of birth, the time of birth, and so many other information will be there. And that will be an authentic record. I request those who are unmuted, please mute so that I can continue. So, the authentic record, and apart from this, the very next day, the baby's father will go to the local self-government body, and there they may register for birth certificate. Again, government is getting a data in that baby's name, and sometimes their grandparents may be interested in horoscope, and they may create a digital horoscope in that baby's name. Apart from this, the baby's father will enter his details or his or her details in the official records of their service book. So there will be another data is created in that baby's name. And sometimes they may even open a Facebook page in the newborn baby's name. So see, all of a sudden how much data is generated in that in a moment in a particular person's name. And when this baby goes to the school, you can see the school will open a record in that baby's name. That will be another data created in name of a student, and that will be stored in that school for a long period. Even after 40 years or 50 years, somebody asking a data about you, that will be there in that particular school. And in due course, you may create a lot of data. I mean, there will be a lot of data will be created in your name. Aadhaar card will be created. Then after 18 years, electoral card will be created. Then driving license, PAN card, the ATM cards, passport. All these are data. All these are structured data. All these are authentic data which is managed in a systematic database, and uh, which is actually governed by a government organization or by a socially responsible organization. So it's a structured data. And we will see what is the data management system or database management system later. So here you can see the data is arranged in a structured format. So we can say that this data is arranged in a clear database or database data management system. So we will see what is data management system. But there are some other data which is unstructured in nature, especially the internet data. The Twitter data, you know, that millions of tweets are tweeted in a day in the Twitter handles, the various Twitter handles all over the globe, and the Facebook, a number of data is created in Facebook, then Instagram, then YouTube, you know, a number of videos are created in the YouTube channels every day. So all these are data. Apart from this, plenty of websites are there. All these websites are updating their data. For example, we are from a university. Our university is updating the university's daily activity. And all these are actually data. It is a record of university's activity. So in some way, it is a data. So all these data are randomly arranged in the internet. So a data scientist is actually mining these data. Whereas the government data is having some kind of a restriction, that is orderly, I mean, arranged data or a structured data arranged in a particular structure that cannot be accessed. Of course, the hackers are accessing, but still that data is somehow safe. But internet, people believe that around 44 zettabytes of data are available in internet at present. Of course, it is increasing day by day. And maybe in the coming 4 or 5 years, the number of data the size of the data will increase. So now we need to consider the size of the data. What is the size of the data? Initially, we discussed what is data. So you have now, I hope you have an idea. There is two types of data. There is a structured data is there. There is random data is there. So random data require various amount of processing. So these are AI, deep learning, machine learning, all these techniques are we are mainly using for random data. Whereas other data, we can simply sort it out using the information system. We will see what is information system. So in our college days, we were using floppy disk, which is 1.4 MB. In fact, I still remember my dissertation, MSc dissertation was fit into this small device. I hope there is no such system existing today, which is compatible with the floppy disk. So it is 1.4 MB in size, and later 700 MB CD-ROM came, then 4.7 GB DVD came, and hard disk and the USB and hard disk later enhanced this data storage capacity. And now we are sitting in the era of cloud computing. So the cloud, we don't know what is the storage capacity of an individual cloud. We know that Amazon is having cloud, Google is having cloud. So we don't know what exactly their capacity is. But this size is normally we explained in terms of certain terminology. So initially we used bits and bytes in the beginning, or when the computers was evolved. Later we discussed about kilobytes and megabytes. In the 80s and 90s, kilobytes and megabytes were big amount or big data. But now we know that our computers and our system are capable of managing TBs and GBs. Actually, we are in TBs now, GBs is gone. But the data scientists are now handling with petabytes of data or exabytes of data. So the available knowledge, I am aware about only zettabytes. After that, I never heard about any size more than zettabyte. You know that around 44 zettabyte data are available in internet, and most probably which may be increased up to 200 zettabyte in the coming 4 or 5 years. Again, we have divisions for the data capacity. Yottabyte and the protobyte and geobyte are the advanced numbers for storage capacity. But most of the people are nowadays, I mean, especially the data scientists are talking about petabyte data and zettabyte data. So in general, Google, Facebook, Microsoft, Amazon, they have a storage of at least 1,200 petabytes, and there are around 300 millions of emails were sent and received every day. Around 5 million videos on YouTube were watched every day, and these are the data statistics. What's happening in the internet? So most probably from the next few years onwards, the Facebook may create around 4 petabytes of data daily. So you can imagine what is the size of the data and where this data is going. So you are going to enter a huge ocean of data. In this ecosystem, you need to create some kind of a management system to structure the data or to reorient the data. So that's why we always depend a data management system. So a data management system is, in simple ways, we can go back to our registration department. So in the registration department's Almara, our title deed documents were stored, and these documents were numbered in a structured format. And that system can be accessed by you as well as the registration department people. But you cannot enter in the registration department. You cannot modify the file in the department. You can simply access your data from the registration department. So data management system is like that. Both people can use data, but the management will be made by certain class of people, and we call it as database management. So database management is a part of data management. So database management is closed, just like, so the difference between data management and database management is very simple, just like driving a car and servicing a car. You can drive your car, but you can't service your car. So, but the service agent can drive the car as well as he can service the car. So this is the difference between database management and data management in a simple sense. Of course, in the IT terminology, you can use different names, you can use the different terminologies for this classification. For a layman, a data management system means you have to store a data in a structurally or orderly manner. You can store the data in, if it is an offline data, you can store in the almaras, you can keep the data in the lockers, or you can store in somewhere it is safe and secure. And only very few people have access towards that data, and they will distribute that data to the respective persons. So that is what we call data management system and database management. So database management is the backend of the data management system. So database management system is restricted, and only very few people have access towards the database management system. So now we have a structure for database management system. So first of all, the database management system will be governed by a body, either a government organization or a private organization, but they should have some kind of, they should have to ensure some kind of a safety of the data management system. Then there should be a specific architecture for the data management system. Architecture in the sense there should be some structures, some structured manner, how you are going to save the data. The data should be ordered, data should be, labeled, data should be categorized. And next is where it has to, it has to store in a systems. If it is an offline system, you can use almaras to store the data, and you can structure the data. You can order, you can number the data, and you can store it in a different racks and different shelves. But in the case of internet technology, we are storing it in the clouds, either in the clouds or the database, but that should be protected by a cloud, the firewall, and no external intruder has to intrude in the data management system. Then we have the type of data which is used in this data management system. You have master data as well as the metadata, which you need to manage. How to organize this, manage in favor of this data management system. Then you have to, if you are using the external data, and if you are importing the external data towards this management system, you need to have a quality control on the data, and you need to sort the data, how you are going to feed your new data in the database management. Then you have to integrate that data to the data management system. Then you have to store that data in, I mean, we all does warehousing. Warehousing means you have to, the newly generated data or the data which is created from the already existing data has to be stored in a structured format. Again, it's a recycling process. Data will be again stored in a specific structured, orderly manner. So that is the job of a database management system. So database management system is actually, I mean, not only managing the data, it is adding new data, but at the same time, it is having a quality control on the new entry. And again, it is internally monitoring the modifications which normally, or routine modifications which happen within the database management system, that we call as the transformation of the data within the management system. This is what we are practicing in the geospatial data science, but data science, of course, in different database management system, different practices are there. But in geospatial data science, we normally practice this structure. Of course, I believe this is the general structure for all the database management system. And I hope you got a basic idea. Of course, those who have database data science experience, they know what exactly data science is. So those who are layman, I hope you got an idea about what is data management and database management and what is data. So now we need to have an information, I mean, we need to have an idea about the information system because geospatial technology, we are having different information systems in the geospatial technology. So what is the difference between a data management system and information technology? Again, I am giving the example of the registration department. This is the website of the registration department. So they have a backend data, and if you want to access some of the data, you can have a query towards their information system. So their website is an information system. You can have a query. Okay, I just want to check the encumbrance certificate of a particular title deed. So they will charge you, and they will analyze that data in fabric, and they will give you some kind of an answer, and that will be a risk. That will be in the encumbrance certificate format. So that means your result is received after, I mean, once you raised a query, you received a result. That is also a data. So one data is passed to you after some kind of analysis within the database management system. So if a system, database management system, is capable of answering queries or passing information, we call that database management system as an information system. Suppose that information, that data is stored only in the Almaraz and it is not passing to any of the third party, we call it as data system or data management system. It is not an information system. But suppose if it is passing to a third party as a result of a query, we call it as information system. So information system is not new for us. You know that in the early days, we used to go to the railway station, a railway counter, there will be an information system. We were used to ask what is the, for example, a person traveling from Kasaragod to Trivandrum. We used to ask the Kanjangad railway station, they ask what is at what time is the next train from Mangalore to Trivandrum. So the person sitting in the inquiry may have some kind of a database in the form of a register or in the form of a timetable. They will just pass through that timetable and they will answer the question. So that is the old way of answering, or that's the old way of information system. And now everybody knows what is how to access the train information. There are simple apps are there. The most popular one is called Where is my train? You can just simply search in that app and you can access the information. So this is the IT version of the old inquiry system. So this is what this is the difference between information system and data management, database system. So database is just a stagnant body, whereas information system, you can collect informations from the database. If the database is passing information, we call it as information system. So now we can move to the geospatial science. So geospatial science, of course, it's not new. Earlier it was known as geomatics. Before that we call it as geoinformation science, something like that. But nowadays everybody use the term geospatial data science. So geospatial data science is the advanced version of geomatics. which were discussing in the previous decades. So let's split this so we get an idea about the geospatial data science. The geospatial data science can be split into geo plus spatial plus data plus science. You know, geo is Earth. Spatial means something related to space. That space may be a two-dimensional space or maybe a three-dimensional space. And of course, data is anything. You can add any type of data with this space. You can club any type of data with the space, and that data can be considered as spatial data. So if it is related to a Earth surface data, we call it as geospatial data. And the simplest explanation for geospatial data is a location-based data, which means any data on Earth's surface is having some kind of a geocoded value. We call it as geocoded data. And what is this geocoded data? Geocoded data is nothing, just a data which is having some tagline of latitude and longitude, or it is having a tagline of latitude and longitude. Then what is latitude and longitude? You know that Earth is divided into latitudinal, longitudinal lines and latitudinal meridians. So if you slice Earth, you know that Earth is a sphere and it is a 300-degree circumference you will get. And if you divide the Earth in two equal halves, the center portion is a horizontal one. And if the line passing through the circumference of the center portion, we normally call it as the equator. And if you draw lines parallel to the equator, you may get different lines from 0 to 90. So those lines are called latitudes. Latitudes are of north latitudes and south latitudes with respect to the equator. And then we have longitudes, which is considered as the vertical lines or vertical circular lines passing through the both poles, North Pole as well as South Pole. Now, what is the significance of this latitude and longitude? Because since it is a 300-degree sphere, you can calculate your position by using this longitude and latitudinal lines. Just the intersection of these two lines will give you exact point on the Earth's surface, and there will not be any repetition for this particular point. And that point is called your location on Earth's surface. It is having two values, that is longitude values as well as latitude values. So maybe x, y values will give you the point on a graph. So that is the basic idea behind this projection. So once you have latitude and longitude values, and if you can fit this latitude and longitude value with any spatial data, we can call it as geospatial data. So in geospatial data science, we are dealing with those data which is already geocoded in nature or which may be geocoded in the future. Now the question will come, how we will enter the attributional data. For example, if we adding a point of a house on a map, and if that map is digitized, we can give a latitude and longitude value for that particular house. But how we will enter or how we will represent the number of members in that particular house. So there we need an attributional data that can be attached with this particular point. For example, in this particular house, there are 5 members and this much female is there, this much male members is there. So like that, you can add the attributional data to that particular point. And you can, you can convert this data from one format to other format. That is the advantage of geospatial data. For example, in the initial data may be a map, and your final output something entirely different from the base map. The base initial initial input may be a topographical map, but your final final output may be a land use pattern of that particular area or a accident network pattern of that particular area. So everything is represented in a spatial format. That means we are representing it in a map format. So that is the result of a geospatial data. Geospatial data is always represented in data science. What you are doing, you are making dashboards actually. So representing everything in dashboard formats. So dashboards are actually used to represent the data in data science, but here we are using maps to represent or a spatial output to represent the data. So that is the difference between normal data science and the geospatial data science. So geospatial data science mainly deals with the the space data or the space related data. It may be a two-dimensional space or three-dimensional space. So now we can move to geospatial technologies. What is geospatial technologies? Actually, geospatial technologies are a bunch of technologies which normally used in geospatial data science, especially the geographic information system, the global positioning system, and remote sensing. These are the three prominent technologies which we used in the geospatial data science for capturing data as well as processing data. So these, let's see what is this geospatial, these three geospatial technology tools. The first one is called Geographic Information System. So Geographic Information System, again, it's a geocoded database management system, which means you are already having an information. So here we are not considering it as data, we consider it as information because in Geographic Information System, you need answers to your queries. So it's an information system, not a database management system. Again, it is geocoded in nature. That's why we call it as a Geographic Information System. Of course, it's a computer-based system, and most probably we are most of the time we are using it in computer only. But nowadays, mobile-based GIS systems are also there. But most of time we are depending on a PC to process the data as well as publish the data. So in Geographic Information System, you are collecting the data from other subset also, just like AI. In AI, you are using, AI, you are using deep learning and machine learning in AI platform. Similarly, here also, GIS is using the remote sensing and GPS data to process the available data with them or to create a new data within the Geographic Information System. So it is again a subset. The remote sensing and GPS is again a subset of the GIS data, GIS system. So the main, I already discussed what is the difference between data and information. So data, once it is stored in the almaras or in the folders, it is called as data. When this data is accessible to a third party, it is called information. If that data is shared among the third party, it is called information. So in Geographic Information System, we are actually digitizing data. Of course, you can use the normal data or the hard copy data you can use in Geographic Information System, but it needs to be digitized. So normally we use the maps and other records. We scan it and then we digitize. Digitizing in the sense, so we are giving the geocoded values to that particular map. So when it is a map, there will not be any geocoded data. So once we scan that map, we will digitize it. We call that process is called georeferencing. So we convert it to a geocoded data, then we transfer to the Geographic Information System. Or we can use the already prepared data, which is already available with a cloud computer or a data hard disk, which can also be transferred to this GIS system. Then or we can enter direct entry, just like a survey data, you can enter through the keyboard directly. Or a manual digitization or scanning is also possible. Of course, most of the time, remote sensing data is a digital data itself. It is directly transferred from the satellite imageries or the satellite processing center. So there is no need of manual digitizing. But sometimes we may get hard copies of the satellite images, so that we need to digitize using manual mode. So that is also we used in the GIS platform. Again, we can use the data directly transfer from the GPS. The GPS will always provide you the latitude, longitude information, and that can also be transferred to the GIS platform. So in GIS platform, the job of a GIS platform is to integrate all this data and you produce necessary output with respect to the user. So in GIS, we will capture all these data in different format. Then we create a database management system within the computer, and that database management system will process all these data. And most of the time we are performing geographic analysis Of course, there are different analysis apart from the geographic analysis. Of course, I mean, there are we have some kind of attributional analysis also, not only the spatial analysis. So in geographic analysis, you can convert one data in one format to another format. For example, if the raster data we are feeded in the system, which can be converted into a vector data, or a vector data can be converted to a raster data, and it all depends on the requirement of the database management or data management system. And finally, you can prepare the result, and the result may be in the format of in the digital format or in a numerical format with respect to the requirement of the user. So this is what we are doing in GIS. So simply, it's a software based operating system, and that is not, I mean, we cannot compare it with a simple software system. It is actually a database management system. So there, you are not storing any data within that software, but you are storing everything in your computer. So in that case, your computer is the database, but the management system is run by the software. So you can, most common software in GIS platform is called ArcGIS. I hope at least some of you might have heard about ArcGIS. It is managed by an American company called ESRI. So there are open source software also, which we normally encourage our students to practice. Now we will move to the next geospatial technology tool, which is called the Global Positioning System. There is a misconception that there is a small handheld mobile-like device is the GPS. So actually, this is not GPS. This is the GPS receiver. In fact, the GPS is having a long history. We will just brief it. It was actually an American defense program started in 1969, and which later full-fledged in the end of 90s. In 1995 onwards, it was fully operational. It is called Navstar GPS actually. Navigational Satellite Timing and Ranging is the full form of Navstar. It is a navigational and positioning system. So the project name or program name is called GPS, not that handheld device name. So we always call that handheld device as GPS. That is just a GPS receiver. Even your car map is not actually a GPS. That is a GPS receiver. So GPS receiver is fitted in an app or in a platform, and you are just using that. So 2000 onwards, before 2000, it was, I mean, the accurate data was available only for the military purpose, either for US military or their allies. But 2000 onwards, it is free of cost available for all the layman's. So nowadays, civilians are also using that. Now the question is, what exactly GPS is? The GPS is actually a navigation and positioning system. Using GPS, you can locate yourself on Earth's surface. So how they, I mean, let's see how they are working. GPS is working with a constellation of 24 satellites. So mathematically, we can cover the entire, 1/3 of the Earth using 3 satellites. So this is all related to the satellite's ground swath and its ground coverage. So 7 satellites can cover 1/3 of the satellites. So they normally use 21 satellites for covering the entire Earth. And 3 of the satellites are normally used as the backup satellites. So around 24 satellites are there in GPS constellations. Now, and the idea behind the GPS calculation is very simple. The receiver will receive the signals from the satellite, and the timing will be calculated. And of course, the waves are mainly electromagnetic in nature. So we know the velocity of the electromagnetic radiation with respect to the velocity and the timing. We are calculating the distance, and based on that distance, a minimum 3 satellites is required to position your position on Earth's surface, and we'll have a triangulation with respect to the distance, and the intersection of the triangulation will gives you your position, exact position on Earth's surface. So this is what happening in GPS. So nowadays we are using GPS in all aspects. I mean, your mobile is having GPS, your car we are using GPS. So we can't live without GPS nowadays. So it's a part of our life now. Now, apart from the GPS, there are other global navigational systems, especially the Galileo, which is a navigational satellite system of the European Space Agency. Then we have a GLONASS system, which is very popular in India. Not only in the receiver, we misunderstand that it is GPS system, but sometimes it may be run under GLONASS system also. So GLONASS is a Russian system actually. China is also having a system which is called a Beidou or Compass. And apart from this, we have our own navigational system, which is called the NAVIC. NAVIC is an Indian regional navigation system. Beidou and NAVIC is a regional navigation system. Regional navigation system means our area of interest is just lies within the Asia Pacific. So we are not covering the entire Earth. We are using 7 to 8 satellites to cover the India and the nearby regions, especially the India's neighboring countries only we are covering. So it's a regional navigation system. I think from the last year, I mean 2018 or 2019 onwards, it is in working state, but it is not available for the civilian purpose. Nowadays, it is used by Indian military as well as the ISRO. So I don't know whether even we are not received any uh, NAVIC-based receiver. Maybe because of the shortage of receiver is the reason. We don't know what exactly why they are not distributing it to the educational institutions. But that system is that system exists, so that is available for the Indian, I mean, government use as well as the ISRO's use. So the next geospatial technology tool is the remote sensing. So I hope you might heard about, most of you might heard about remote sensing. So remote sensing is, if we say simply, it is an art and science, art plus science, because it is not fully science, it is a skillful science. It's a skillful job, so that's why we call it as art plus science. So it is the process of studying an object without going near to that particular object. You can study a distant object without going near to that particular substance. So that is called the remote sensing. Most of the time we are depending satellites and aerial photographs, satellite imageries and aerial photographs for the study purpose. Especially satellite imageries are using because it is very cheap and freely, I mean, most of the time it is freely available. But aerial photographs are very high cost data, so we cannot, most of us cannot afford the aerial photographs. But the drone photography has changed I mean, the horizons of aerial photography, because nowadays everybody is having the Chinese drone. So that drone is also capable of taking aerial images, geocoded aerial images that can also be used for remote sensing. So remote sensing is the study of a distant object without going near to that particular object. So in remote sensing, what we are doing is we are either we are using any of the electromagnetic radiation for the purpose. It's just like if you take a photograph using your mobile. You are taking the photograph with the help of a visible light in the daytime. If it is in the nighttime, you are using flashlight to take the photograph. Just like that, we are fixed sensors on the satellites. This sensor may be either CCD cameras or infrared cameras or sometimes any other radar sensors. And we normally use ultraviolet to radio waves for remote sensing, because gamma rays and X-rays are not using because of their short wavelength. A longer wavelength radiations are normally using, and visible wavelength are mostly using during the daytime remote sensing. In the nighttime, we are depending on the infrared as well as radio waves. So the theory is like this: we depend a source, data source, which may be a natural source or an artificial source. Most of the time, we depend sun, as because the sun is the prime source of electromagnetic radiation. So that radiation will reflect from Earth's surface. During the reflection, that reflected light is having some kind of a signature of the reflected platform. So that may be a small plant or small terrace, or maybe a small rocky surface. So from wherever it is reflected, that information will be there in that reflected light. So based on that, we are capturing that information, and we are processing that data, and then we are preparing the satellite images, and that will be sent to the ground station. There the ground station will process the data and send to the users. So that is what we call the satellite imagery. So different types of remote sensing. The ground remote sensing is there. If you are taking the photographs using the help of a pole or the help of a crane, or if you are taking photographs from the top of a mountain or from the top of a high-rise building, it is called ground remote sensing. And if you are using low-flying objects like drones or helicopters, normally we are not using helicopters because helicopters is having distortion. So drones are okay. Drones are using nowadays. Low-flying aircrafts are also using for remote sensing. Then high-altitude jet planes, mostly defense purpose, they are using. So the defense remote sensing data is having good quality, but the accessibility is very limited. Then we have a space shuttle. Now that space shuttle program is not there. Previously, NASA was using space shuttles to send the logistics to the International Space Station. So they were having 4 space shuttles named Enterprises, Discovery, Columbia, and Challenger. I hope you might heard about the Challenger and the Columbia disaster. And we lost one of our space scientist, Kalpana Chawla, in the Columbia tragedy. So these space shuttles were once they were traveling to the International Space Station, they were used to take the images of Earth's surface, and that is called Shuttle Radar Topographic Mission. Normally we call it as SRTM. And that data is also available in the internet free of cost. That is the most, the most useful digital elevation data available on the internet. People are using it for the mainly for the study, the terrain studies. Apart from that, there are different types of satellites. You might hear about the polar orbital satellites and geostationary satellites. So geostationary satellites are long distance satellites which is stationary in one position, whereas polar orbital satellites are those satellites which is revolving around the Earth 24/7. So those satellites are also very, those satellites imageries are very useful because they are continuously monitoring or continuously feeding the images from a particular position. Whereas geostationary satellites is fixed on a particular point, but at the same time, it cannot be, or you cannot access different places using that particular satellite. Whereas polar orbital satellite is continuously revolving around this Earth, that can be used for different or multiple sensor can be fixed on this type of satellites. So that can also be used as a remote sensing. That data can be used for remote sensing purpose. So this is the general concept of remote sensing. And in remote sensing, in geospatial technology, we use various platforms to, or various, software platforms to process the data. So especially image interpretation as well as the image processing, we are using remote sensing software. And GIS management, we are using the GIS software. So the most popular image processing softwares are ARIDAS Imagine, which is high capacity, which is a very capable high capacity software which can process high capacity data, satellite images at a stretch. So most of us are using this ARIDAS Imagine for the remote sensing. Apart from this, there is one more software is there, which is called ENVI. This is published by Harris Technologies USA. It is also capable, but most of the people prefer ARIDAS Imagine over ENVI, but still ENVI is also a potential software which is used in geospatial technology. Then now we have the most powerful GIS software, which is called ArcGIS. So this software is using in all the globe because this is the most popular GIS software nowadays. So it is capable of doing both geospatial as well as the remote sensing, geographic information system as well as remote sensing job. So we all are practicing this. Apart from this, we have open source softwares, which is called QGIS. QGIS is also capable of doing these geospatial jobs. So it is just like your AI platform in the data science. We are using this. This is also AI based. And of course, we can customize this softwares. That is the advantage of this software. Some of the tools we can customize using Python or SQL form. So that is the advantage of geospatial softwares. Again, we are using it for various purposes, not only for remote sensing. We are using it for geographic information system, some other database management. This is the backend of the database management system also. There are web servers associated with these particular softwares, and web server is capable of publishing the queries, and then this database management system will become the information system. Now, the question is, what is the application of geospatial technology? So I will share one of my experience. Then I think there are plenty of applications. So it itself take around 2 to 3 hours to explain one single application. But I will share a very small application here, and after that we will generally discuss the common applications. So a few years back, I got a call from Paris, France, for a conference, and the conference venue was in Moschnever. So at that time, I was not aware about this place. So what I have to do, I just searched in the internet, and I just called to the Google Map. I searched the Moschnever in the Google Map, and Google Map just shown me that particular place, and I came to know that it is on the border of Italy and France. But the next question was where I have to land. So that was my second question. So I zoomed out a little bit, and I came to know that the most famous airports near to that point is either Paris or Milan. These are the two common airports, not common access airport from Delhi. So I choose Paris because I was having previous experience there. So I was a little bit comfortable there. I chose to Paris. While returning, I thought anyway it is near to Milan. I taken a flight from the Milan. But at the same time, I don't know where exactly this place comes. Then I searched in the internet. I found that there are trains available from Paris to Milan. So there are high-speed TGV trains as well as the Train Italia trains are available. So I found one of the nearest railway station near this particular point. So I found that Olux is the nearest railway station. But I have no idea. I've never heard about that place. What I have to do, I just searched the same in the satellite mode, and I want just a clear picture of that particular area. So again, I zoomed it that, okay, now I got a clear picture of that particular area. Without going that particular place, I got an idea about that particular place. So now I got, okay, the information that the platform is on this particular side and the bus stand is on this particular side. But I'm not happy. Then again, okay, sorry. Yeah, I don't know why it is not working. Yeah, now it's working. I was searching for more details. So I just taken the street view out of the Google map, and I just placed that street view in front of the railway station. So I got a clear picture of that railway station premises, and then I can capable of zooming in that particular area. So I searched the bus stand near. So from this bus stand, I need to go to the Moschnever. So I got an information without going that particular place. By sitting in my room, I searched that particular place, and I have got a clear idea about that. Now it was just an example, because before going there, I just had a virtual walkthrough through the platform. Even I visited the ticket counter also, so that it was easy for me to find out that place. So this is actually the application of geospatial technology. Without going that particular place, by sitting in your office or in your home, you can process, or you can have plenty of information using geospatial data science. So Google Map is the best example for geospatial data science. There you have a geocoded maps, and these maps are having n number of information. Suppose if you want to go there, a particular place, you can go there. Before going there, you can virtually go there, and you can have an exploration there. Then you can fix, even during my trip, I virtually visited the hotel, and in front I visited the nearby metro station also. So I got an idea, okay, after getting down in this particular metro station, I have to walk this much distance, and then there is my hotel. Similarly, you are using Google Map in your car. You are while driving, that sweet lady is telling you that, okay, in 500 meters you turn right, in 400 meters your destination is on right or left. So like that, you are getting a clear information in an unknown place with the help of geospatial science. So that is the advantage of geospatial science or geospatial technology. Apart from that, a number of applications are there in geospatial science or geospatial technology. The most important applications I have mentioned here. In energy forecasting, we are using geospatial data. You know that the energy lines or power grids is transferred through the high tension lines. And who planned these high tension lines? Earlier, the British period, the people used to visit the place and they surveying that place. Nowadays, it's over. Survey is done through the aerial platform. You might heard about the most hot topic in Kerala is the K rail. The survey of the K rail was performed through the aerial survey. Nobody visited the land, and there was no such kind of a land-based survey for that particular project. That's why people were afraid, because they said that there was no survey. But nowadays, there is no need of land-based survey. You can precisely survey the destination or survey the route through the aerial platform. That is the one advantage of geospatial. Then agriculture field, if crop, I mean the planning of the agriculture field, as well as even you can monitor the cloud patterns and wind patterns using remote sensing. So that's also an advantage for the farmers to identify the seasons for their particular crop plantation, other things. Again, the carbon footprint management, you know, that the global warming is a hot topic now. So geospatial science is using to monitorize, especially you might heard about what we call the Gargill Committee report and other things. So the Western Ghats Preservation report and other things. So all these things were actually prepared. All these things were prepared with the help of geospatial data science, because we cannot, you can imagine the size of the Western Ghats, starting from the Trivandrum in the south to the Ratnagiri or Panvel in the north. There, up to that point, you can imagine what is the size of the entire Western Ghats. And now, if you want to survey manually, you can imagine what is the time required for to survey the entire Western Ghats. But instead of that, if you can download 1 or 2 satellite imageries and you can process the data very easily. So that is the advantage of geospatial technology in the climate studies, as well as the ecosystem or ecologically fragile areas management. Then aviation industry, people are using the GPS when most of the flights are now operated on the basis of GPS technology. So geospatial technology is also supporting in the aviation industry. Then homeland security, you know that most of the defense projects are actually run on the basis of GIS or geospatial technology platforms, because the real time, during a war or during a crisis time, the real time monitoring as well as the proper understanding of the terrain is very important. So people are using GIS, the GT in the homeland security. Then and community growth, especially the road network development as well as the urban planning, we are mainly using GT, and most of the smart cities are actually planned with the help of geospatial technology, especially the aerial photo, with the help of aerial photography and geographic information system. The government is planning everything on this backend. So again, it is very useful in the community growth. The disaster management, you know that the Kerala's condition is getting worse every year because of this climate and climate change and the monsoonal variation. So disaster management sector, government is using it. These GT government organizations as well as the scientific organizations are using geospatial science widely. And public health, we are, that the past 2 years, we are sitting in most of us were sitting in home ideally because of this corona pandemic. And that in the initial days of this COVID pandemic, if we have a database management system based or health information system, we would have to manage this crisis a little bit, because unfortunately we don't have a health information system in our state, not only in our state and in our entire country. We don't have a health information system. If it was there, easily we can track the movements of the patients as well as the clustering of or hotspots of corona. You can easily handle this situation in the initial days. But so far I don't think we have current. I mean, at this stage also we have a public health or a health information system, but still it's a very useful thing for a civilized community. Again, coastal management and the land use management is again a part of the information system. I mean, it's a part of geographic information system. So we are using it, the land use management as well as coastal monitoring. You know, the coastal area is the most vibrant area where during the monsoon time we have a violent sea attack along the entire coastal belt. So that time we need to manage, I mean, the construction of the resistant wall construction or some kind of a defensive mechanism against the erosion is also required in this particular area. So all these can be managed by GIS. And finally, the water. The most hot topic in the world is water. I mean, the people, not only the WHO, the entire UN is actually behind these water management plans. Most of the African as well as the tropical countries are having this water scarcity, and the water management as well as the water exploration is another hot topic in the geospatial technology. So in total, geospatial technology is an advanced information technology based tool which we are using in our present day, and its use is also increasing every day. Most of the, I mean, it's a integrated topic. It's not a purely geological topic. It's actually the integration of computer science or information technology and the earth science. So it's an interdisciplinary topic. So I hope in the coming years, geoscience technology or geoscience database as well as geoscience, geospatial data science will contribute much more for the development and the betterment of our community. Thank you.
Thank you, sir. It was really a wonderful session, and you have given a very informative and very elaborative session on this geospatial data and geospatial technology. And I think the participants, all the participants have benefited it, and they can do further studies and researches using these type of data and analysis. And now the participants, if you have any questions, you can ask. If any queries or doubts or any clarification you need, you can ask to the resource person. If no doubts or any queries, then Pindima ma'am, can we wind up the session?
Yes, yes.
Okay.
Aditya,
So,
there is an announcement for the students. Please fill the feedback form that I have shared through the chat box.
okay.
So thank you so much, Sir Pradeesh, sir. That was a wonderful session. In fact, that our students or those who have interested in image processing, and also they might have benefited. So thank you so much for your time and your nice presentation.
Thank you, ma'am. I don't know how much it is benefited for the students because I was a little bit in a hurry. So I don't know whether I have touched all the points on geospatial technology because as you know, we were a little bit busy behind the convocation ceremony. So I
Yes.
given the brief idea about the geospatial science and the application or the potential of geospatial science. In fact, we have a full-fledged geospatial science laboratory in Central University of Kerala. If any of you are interested in geospatial science and data processing, you can contact us. You are always welcome to our laboratory. Thank you.
Yes. Thank you so much, sir.
Thank you. Shall I leave?
Thank you all once again. Thank you, sir. And participants, please fill the feedback form which is shared in the chat box.
So now you can leave, sir.